For this video, we're going to be finding trig ratios by analyzing signs. To start with, let's remember our quadrants. We are in quadrant 1, and my x value is positive, and my y value is also positive, right? It is usually the quadrant where we work at the most. On the other side, on quadrant number 2, I have a negative x, but I still have a positive y. On quadrant 3, both x and y are negative, and on quadrant 4, I have a positive x, but a negative y. That is going to be important because what we want to do now is analyze angles that are not in quadrant 1. If we want to analyze non-acute angles, so angles that go into quadrant 3 or 4 or 2, what is it that we're going to do? Before we moved, I just want you to have in your notes what sine is. So remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is going to be opposite over adjacent. And remember that the reciprocals, secant, cosecant, and cotangent, so cosecant of theta is 1 over sine, so we're just going to flip the information that we have. Secant is 1 over cosine, and cotangent, that's CC, it's going to be 1 over tangent. So we're just going to flip the results that we have for sine, cosine, tangent. So what do we do? So in this first example, the instruction is find the trig ratios of angle 300 that passes through the point x and y, so a very generic point in a unit circle. Remember that unit circles have a radius of 1 because they are the unit. So we'll just draw. The first step is just knowing where your angle is. Always draw your angle so you know what you're doing, what you're talking about. So angle 300 is going to be somewhere. This is a sketch, remember? It's going to be somewhere over here. We know that the 300 went all the way here. Remember, this is 90 degrees. This is 180 degrees. This is 270. So it's somewhere in my fourth quadrant, somewhere over here. So that's my angle. This is my angle 300. So next, I'm going to find the reference angle. Remember that the reference angle is the angle, positive angle, so between 0 and 90, positive angle that takes me to the horizontal line. So in this case, if this is 360 and I have 300, my reference angle is going to be 60 degrees. That is how far away I am at from my horizontal line. So I'm going to be working with my reference angle because my reference angle, it's going to give me the same information as my actual angle. So now let's get the trig ratios for this reference angle of 60. So I have sine of 60. And remember that I have a generic point. Let me put it over here. I have my generic point xy. So I can trace a triangle, right, with a radius of 1. Let me switch my color. This is my x. This is my x, this is my y, and this is my radius. So with that information, I'm going to be getting my trig ratios. Okay, so we were sine of 60. If this is 60, my opposite is my y value, right? So I'm going to have this y value over the hypotenuse, which is the radius of 1. So I'm going to have that sine of 60 is y over 1. Then I'm going to have cosine. So cosine of 60 is going to be x over 1. Now the tangent of 60 is going to be the opposite, so the y value, over the x value. All right? The reciprocals, again, are just flipped. So cosecant of 60 is going to be 1 over y. Secant of 60, it's going to be 1 over x. And cotangent of 60 is going to be x over y. Okay, so now we have that information of that triangle. Now I want to analyze the signs. Remember that in quadrant 4, my x is positive and my y is negative. So let's put the signs for each x and y. The radius is still 1. It is still a distance. It doesn't carry a sign. And see what my trig function is going to be. So my y is negative, so sine of 60 is going to be negative. My cosine is positive, so I'll just leave it like that. My tangent is going to be a negative y and a positive x. My cosecant is going to be a negative y. My secant is going to be a positive x. And on this one, I'm going to have a positive x and a negative y. So for my angle 300, using my reference angles, for my angle 300 degrees, my functions sine of 300, sine of 300, tangent of 300, and cosecant of 300 are all going to be negative values. Now, for my cosine of 300, and then my secant of 300, I'm going to have positive values. In my negatives, I'm also have the cotangent. They're going to be negative. So see, as we analyze the reference angle, and remember reference angle, that was why it is so important. For the reference angles gives us the number, but the analysis of the quadrant gives us the sign. What happens, for example, we're going to follow the same 4 steps. What happens when we have an angle of 100? So let's first do the sketch so we can position ourselves in the quadrant. So remember, this is 90 degrees. This is 180 degrees. This is 270. And this is 360, or of course, our 0 degrees. Okay, so my angle 100, it's going to be somewhere over here. So this is going to be my angle 100. Okay, so what is the reference angle for 100? Remember that it is the positive angle that passes, the positive angle that gets me to my horizontal. So my reference angle is going to be 80 degrees. And with that is how I'm going to start. My points are, again, a generic point, x comma y. So I'm going to have, this is my y, this is my x, and this is the angle that I'm going to be working with. Okay, so to get my my functions. So I'm going to have the sine of 80 is going to be opposite over hypotenuse. We're still working with a unit circle. The cosine of 80 is going to be x over 1. The tangent of 80 is going to be y over x. And the reciprocals, again, I'm just going to flip them. So I have 1 over y. Secant is the reciprocal of cosine. So I'm going to have 1 over x. And then the cotangent is going to be x over y. Okay, so now let's see the signs. In my second quadrant, my x is negative, but my y is positive. My x is negative, but my y is positive. Okay, so my y is positive. My x is negative, so it's negative. And then on this one's, my y is positive, but my x is negative. My x is negative, but my y is positive. So I can see for the tangent and the cotangent, I'm going to have a negative function. All right? Okay, so now if I want to have the information for angle 100, I can say the positive trig ratios are going to be sine, they're going to be cosecant, they're going to be, and that's it, right? Now my negative ratios are going to be cosine, secant, tangent, and cotangent. So the measure of the angle is going to be given by the reference angle. The measure of the ratios are going to be given by the reference angle, but the signs of your actual angle are going to be given by the analysis of your signs. Okay, now we don't have a generic point. Now we have an actual point. So let's see what the difference is if we have this type of information. Okay, so we want to do, I'll keep this. So this is 360, this is 270, this is 90, and this is 180. Okay, so now we have a point -2, -4. Let's see where that is. -2, -4. So somewhere over here. And we have this angle form right here. Okay, so what type of triangle are we going to have? We're going to have this triangle right here. And we know that the distance of x is going to be 2. And the distance of y is going to be 4. That is all that we need. And now, since we're not working in a unit circle, we need to find out what the hypotenuse is going to be. So the hypotenuse square is going to be 2 square plus 4 square. So we're going to have 4 plus 16. We're going to have 20. So my hypotenuse is going to be the square root of 20. And the square root of 20, although it doesn't have an exact value, we can just simplify it as 4 times 5. So it's 2 square root of 5 because the 4 does have an exact square root. So that is the value that we're going to work with for the hypotenuse, 2 square root of 5. Okay, so now let's get some trig ratios. So we have sine of theta. So the reference angle made by this point is this one right here, right? Okay, so my opposite is going to be 4, and my hypotenuse is going to be 2 square root of 5. So I can simplify it, and I will have 2 over square root of 5. So I'm going to keep that one. Oh, I can even simplify it by rationalizing, and I would have 2 square root of 5 over 5. Okay, so now the cosine. So the cosine of theta is going to be 2 over 2 the square root of 5. So 1 over the square root of 5. I rationalize it, and I get square root of 5 over 5. Okay, the tangent is going to be simpler. The tangent is opposite over adjacent, so tangent is 2. And now the reciprocals are going to be cosecant, which is going to be 2 square root of 5 over 4. So I'm going to have square root of 5 over 2. Secant is going to be 2 square root of 5 over 2, which is just square root of 5. And cotangent is going to be 2 over 4, which is 1/2. Okay, so now let's analyze the signs. For quadrant 3, I have negative and negative, which you can see by the signs of your numbers. So if we have negative and negative, my distance, my radius is always positive. So I'm going to have a negative 4. So this is going to be a negative trig ratio. And then I'm going to have a negative x. So here's my negative x. So this is also going to be negative. And for the tangent, I'm going to have negative, negative, which gives me a positive function. I erase the 2, a positive function. Okay, so now let's see the reciprocals. We're going to have a negative, so this stays here. We'll also have a negative, so this stays here. And negative, negative give me a positive. So in this case, all of my trig ratios are going to be negative, but tangent and cotangent. So I have negative I'm going to have the sine, the cosine, and its reciprocals, cosecant and secant. And for the positives, I'm going to have tangent, and I'm going to have cotangent. So if you see, that is a great way not to memorize your which is positive, which is negative where, but actually think about your signs when you're drawing your angles. My best recommendation is to actually draw the angle and then do everything else, and after do the numbers.